Well, that's an unexpected change of events. So we are going to have a video of page 4 in your packet. I want you to try the problems along with me. Your homework is page 5. So similar to the first day, we're going to do the same properties. I'm going to put some arrows on my graph. Where the graph runs into the edge of the grid, the graph continues on. For number 5, pause the video here. Try the properties from yesterday. See if you, or from the first day of school. See if you can remember and fill in those values, those properties. Okay, for domain, our graph goes all the way to the left, all the way to the right. So you can write the interval notation negative infinity to infinity, or you can write x is all reals. Both are acceptable answers. The range, I notice our graph goes down forever. And let me label this point. This is at 2, 4. So the range, we start at negative infinity, and the y values stop up here at 4, but including 4, so I use a square bracket. For minimum and maximum, minimum would be a low point, not including infinity. You cannot include infinity, so there is no minimum. And maximum is the highest y value. Just list the y value. It's not a coordinate. For increasing and decreasing, we have to read our graph left. Oh, I can't see that color. Hang on. From the left, negative infinity, all the way over to positive infinity. So as I start on the left, this part of my graph is going up, up, up. This is increasing. We're going up, 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 up. And here at 2 is where our graph changes to going down, 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 and decreasing. So increasing interval is negative infinity to 2. But not including 2, we use a curve bracket. And then decreasing, we start. Sorry, the announcement cut me off. So we don't include 2. It's never a square bracket on increasing and decreasing. Then decreasing, we continue from 2 to infinity. For the decreasing interval. So boundedness goes hand in hand with the range. If you look back at your notes from the first day, your choices for boundedness are above, below, both, or none. So when I look at my range, it's stopped at the top. The graph is stopped up here at the top, so its boundedness is above. It is bounded above. Okay, pause the video here and try number 6. I'm going to label this key point. This is at 2, 1. Domain is from negative infinity, and we stop here at 2. So negative infinity to 2, but including 2. And the range, since this is going to continue down, if I start at the smallest number, negative infinity, and then we stop at 1. When you write your intervals, you have to go from small number to larger number. It has to be in numerical order of a number line. You have to go from small to big. Minimum, there is none. The maximum point, this y value is 1. As I walk on my graph left to right, this entire function is increasing. It is going up on the entire domain. So from negative infinity to 2 with no decreasing. For number 6, the range is stopped on the top, so the boundedness is above. Okay, I know in the packet, I think these numbers are slightly different. I'm sorry, I should have said that in the beginning. The graphs match though. All right, so let's take a minute and look at 7 and 8. In the packet, I think those numbers are much more clear. Pause the video here and try 7 and 8. Okay, I actually got my packet out. The numbers match. Sorry, that was a mistake. Our numbers match. The numbers here, the coordinates are much easier to read in the packet. Okay, for domain, this part of the graph continues all the way to negative infinity. This one goes all the way to positive. So we got negative infinity to infinity. You could say x is all reals. For range, the graph continues down and up, so the range is all real numbers. Or you could write y is all reals. The minimum, never infinity or negative infinity. But this point here has a y value of negative 1.079. And this point here has a maximum, a y value of 5.079. I'm going to color code my graph. You've got increasing until this x value, decreasing to this x value, and then increasing again. So for increasing, that is negative infinity to negative, I'm not going to have enough room. Hang on. Increasing, let's do this. Negative infinity to negative 1.155. And, union is and, again, from positive 1.155 to infinity. That's this interval. Decreasing, the decreasing interval is this middle section. And in this middle section, the interval is negative 1.155 to positive 1.155. For boundedness, our range is all real numbers. So that's not bounded at all. There's no stopping point. That's not bounded. All right, last one. Try number 8. Domain, x is all reals. Range, y is all reals. Minimum is the y value down here, negative 4.104. Maximum up here at the top, the y value, 2.03. Let me color code my graph. decreasing to this x value, increasing to this x value, and then decreasing again. If it also helps, you can, on your x-axis, go negative infinity, negative 1.786. That's a little squishy, hang on. Negative 1.786. And then this value, 1.12, and then out here to infinity. All right, we are decreasing from negative infinity to negative 1.786. And then the graph is increasing from negative 1.786 to 1.12. And union again decreasing from 1.12 to infinity. The range is all real numbers, so no boundedness, it's none. Your homework is page 5. Be sure to check your answers in the posted notes in Google Drive and enjoy the rest of your afternoon.